Hello, everyone, and welcome to the AI and Data Roadshow. My name is Juan Llovet. I am a partner solution architect focusing on data and analytics. Today, I will be talking about Azure AI Vision. I will be giving you an overview of what Azure AI Vision is and the different models and capabilities offered within Azure AI Vision. Following, I will give some considerations about responsible AI that are important to keep in mind while developing solutions with Azure AI Vision, and I will be talking about the pricing as well. We will then move on to a walkthrough of the Azure AI Vision portal, which is the main way to interact with these models if you're not using the APIs. There's also the option of using the APIs with these models, but for a brief overview, the Azure Vision AI portal, and to start any project, it is the adequate place to start. And I will also be giving a hands-on demo of how to train your own custom vision model with manual image labeling in a very easy and intuitive way so that you can get started right away with your projects with Azure AI Vision. So to get started, what is Azure AI Vision? It is a suite of services that we offer under a same umbrella that are dedicated to using computer vision in a variety of use cases. These are pre-trained models for the most part, which are designed for various different tasks, with the option of also training your own custom models to classify and detect objects in images, and as well as modifying the existing models and tuning them to specific use cases, such as setting thresholds of detection and setting different categories that you want to look through with your model. If you look at this slide here, if you see at the bottom, we're going to be talking about Azure AI Services. Azure AI Services is the Azure resource you need to deploy to use Azure AI Vision. There are other non-vision related services as well included in the Azure AI Vision resource, but all of these services are pay as you go, that is pay per use. So for example, if you only want to use the Vision services that we offer, you still would need to deploy the same Azure AI services in the same resource in your Azure subscription, but you wouldn't be charged for anything that you weren't using. So once you have that resource deployed, what can you do within Azure AI Vision? With image analysis, there are a variety of models available in these different categories: detect, classify, caption, and generate insights. They are designed for specific use cases and each offer different features to achieve what you're trying to do with computer vision. To keep in mind, these are models for still images, not for video. And it is in this category where you can train your own custom models, which we will get into further on. The next category is spatial analysis. This suite of models is designed to analyze video in real time. Therefore, these models are made to be deployed on premises on the edge, whether it is through an IoT edge device or in a container in your own device in the edge, basically processing the video closest to the source to get these insights as quick as possible. The training is still done and the setup is still done through Azure AI Vision. But basically what we're trying to get at with spatial analysis is analyzing presence of people and objects and movement through space in real time. This is useful because you can set your own parameters, your own areas, your own lines, and you can set your own rules of what the model is supposed to detect. For example, if you're using this in a restaurant, you can see how many people are waiting, or if you're using this in a factory, you can label a zone a safety zone, and if the model detects someone has stepped into the safety zone, then that can trigger some sort of alert to prevent an accident. Further along, we have character recognition. These models are focused on extracting text, whether it is printed or handwritten, from a variety of documents and in a variety of styles, such as handwritings or different fonts. So basically, the idea of character recognition is to send documents to the cloud and then receive a response of what there is written or typed in these documents to use it for any application that needs to read a document. And our last models are the facial recognition models, and they have two main purposes: to recognize human faces and then also verify human identity. With the correct setup, you can distinguish between people with these models. And as you can see on top of these services is the Azure AI Vision portal, which is the main way to interact with these models, especially in a testing environment where you're figuring out which model you might want to use for your specific use case before you go and you implement it into your application. It is very important to keep responsible AI in mind when developing Vision AI projects due to these models being able to have a real-life negative impact if not treated responsibly. On the left, we can see some responsible AI considerations. Safety indicates that the model should not create situations of danger. Fairness, that everyone is treated in a fair way, as opposed to the model creating situations where people would not be treated normally due to the model making wrong decisions in important decisions that have real life impact. Privacy is that the model is not revealing or collecting information from individuals that would not have been surfaced if the model wasn't present, if it wasn't being used for that use case. And inclusiveness means that the model has been designed to make sure that every single group that is using the model is treated in an equitable fashion and that there is no inequity in the model due to its training. If we look at the spatial analysis models, safety is one of the biggest considerations in the scenario that we were discussing, where it's a factory floor and you're designating safety areas to make sure workers don't get into dangerous situations. This model should not be your only safety mechanism. You should have backups as well in case the model fails. So in any use case for the spatial analysis model that you're 100% in the model working all the time, you should always have backups, whether it is other sensors and programs or people supervising the model. Fairness, this model should not be used for example, employment decisions such as tracking employees in factory floors, because while the model does provide some statistics about people and their movement, it does not always provide this within a right context, so it shouldn't be used for decisions which might have negative outcomes. Privacy, this model should never be used in protected spaces where you wouldn't have a camera streaming real-time video. That's an important consideration to keep in mind with this model. And inclusiveness is that this model should be evaluated for every use case, as it has been trained mostly in population of 18-year-old through 65. Therefore, it might not be as reliable on every single population or in any single setting. So it should always be evaluated that it is going to work correctly for all the intended users. When looking at optical character recognition, we see that in terms of safety, in a similar manner to spatial analysis, this model should not be used when serious adverse consequences are possible. In this case, an example could be dispensing medication from a handwritten prescription. In these use cases where identifying the wrong text might lead to severe bad consequences, this model should be always monitored and not allowed to make decisions on its own. In terms of fairness, this model should also be supervised in the same manner that I mentioned previously when it is making important decisions, such as reading forms for benefits and deciding whether to give someone a benefit or not, depending on how they have filled out the form. Again, you must keep in mind that the model might fail, might produce wrong results. So it should always be used responsibly and monitored. And finally, in terms of inclusiveness, this model should not be used for signature recognition due to all the signatures being different and being very difficult to be recognized by machines. So this model should not be used in that case where you want to validate a signature to make sure that a document is correctly filled out or not. The facial recognition model is the most limited model in terms of responsible AI. To be able to use this model, you must submit a use case and have it vetted by Microsoft. For example, Microsoft does not allow the use of these models by law enforcement agencies. In terms of fairness, this model should not be used to determine service eligibility of people or classifying people into different service categories based on any traits that the model might identify. In terms of privacy, this model should not be used to infer private information. This model is designed to identify people and validate their identity. It is not designed to obtain traits from people such as emotions, which has just been deprecated, or political affiliation, gender identity, or any other private category. This model should not be used for these use cases. Additionally, this model must be supervised and not used in case of mandatory enrollments to comply with our inclusiveness principle. A good use case for this model, for example, would be a touchless entry into a concert venue to avoid any issues with tickets, but it still should be supervised to make sure that if the model were to fail and not correctly identify someone, those people wouldn't lose their tickets, or any similar case would apply in supervision for the model. In terms of pricing, all the image analysis models are priced in a similar way. They are categorized into two groups, Group 1 and Group 2. Group 1 is every service except describe, read, and generate captions, which is considered Group 2, which are more expensive than Group 1. As you can see, it depends on the number of transactions a month. The more transactions generated a month, the cheaper each transaction is. That is a call to the API. So we start at less than 1 million for Group 1, and we start at $1 per 1,000 transactions, and it goes all the way down to 40 cents per 1,000 transactions if you generate more than 100 million transactions a month. Group 2 is priced at $1.5 per 1,000 transactions for anything less than a million, but it's priced at 60 cents per 1,000 transactions for anything over a million. Therefore, it is not categorized in those other three buckets. It's just once you get to 1 million, it goes lower to 60 cents. Customizing a vision model has its own pricing. It is priced at $20 the hour of training that you can configure your training budget in the Vision AI portal, and $2 per 1,000 inferences, so it is more expensive than using a pre-trained model, and this model should only be used in the case that it is really needed. Additionally, training this model might incur other charges, such as deploying an Azure machine learning workspace. And in terms of the visual analysis, the spatial analysis model, it is priced at $0.0108 the hour of analysis. These models are designed to be run on the edge. That is, you provide your own edge device and your own cloud connectivity. And based on how many hours of analysis each camera does, this is the pricing of the model. Welcome to the Azure AI Vision Studio. Once you deploy an Azure AI Services resource on your Azure subscription, you can access the Vision Studio and check out all the different models. As we were mentioning, there are four main categories that are represented here: optical character recognition, spatial analysis, face, and image analysis. Image analysis is where you will find the biggest number of capabilities. We can see that, for example, you can deal with captions, you can detect common objects or extract tags from images. Let's take a look at detecting objects in images. In this case, we'll have a variety of images that we can test out. And here we can see that the model detects a subway train and two people here, and it labels everything that it detects individually, and it also gives you confidence labels here. So, for example, if you modify the threshold value, you can make it so that the model only identifies something if it is very sure of it. In this case, we have raised it, and for example, one person, the one in the corner, has disappeared. If we go back to image analysis, for example, we can generate captions from images. And here we have different scenarios. And if we submit this image with the cows, for example, it will tell us there's a group of cows grazing in a field. And again, you can see the JSON response with the different parameters that the model gives back. And in this case, for example, we'll have a man holding a surfboard on a rock. But we can go beyond this with captions by adding dense captions to images. So if we have this scenario, for example, the model is going to give us a multitude, a collection of sentences describing the image. For example, here it is a woman sitting on a couch with a laptop and a dog, and that is the bigger detection. But then it goes specifically within different objects, such as the candle or the cup on the table. And if we take a look at the JSON, it gives us the bounding boxes and the confidence of every dense caption that it produces. Therefore, you can treat these items individually when you receive the response within your application. Moving on to spatial analysis, you can count people in an area, detect when people cross a line, or when they enter or exit a zone, or you can also monitor social distancing. One of the best features here is detecting when people cross on an area. In this case, we're looking at a store, and we can see when there is a customer that is going to walk into the store, and the model is going to recognize that. You can set up your own detection boundaries to tell the model what you want it to be looking out for. The other spatial analysis capabilities, for example, allow you to count people in an area. In this case, you can not only see if customers enter, but you can see how many customers there are at any given moment within an area that you draw. In this case, you are interested of this view of the store, but if you change the area, for example, you could see how many people there are in line for checkout. And one last feature that is still in preview, but it is very impressive, is video retrieval and summary. In this case, you can provide a video to the model, and the model will summarize the video for you on the whole running time of the video. It will tell you, for example, in this case, what are noteworthy events that occur in the video. Someone spilled liquid, an employee mopped the floor after, and then a woman fell on the ground, for example. These are noteworthy moments according to the model. So in that case, when you have your summary, you can choose to ask specific moments of the video. For example, was there milk on the floor? And the model will tell you when there was milk on the floor. It detects the milk in there, and you can jump to those frames in the video to see what happened and to analyze the video depending on what you obtain through the summary. And to end our session, I will show you how to train a custom model. So if you come here to the Vision Studio and you select the Customize Model with Images option, it takes you to this screen and it allows you to select the resource you have deployed. In this case, I already have trained a model, a custom dataset, but I will show you the process of doing so. You would start by adding a new dataset and you would give it a name, for example, demo. And here you can select image classification, object detection, or product recognition to train an image classification model, which is what we're going to do now. We provide our own images within an Azure Blob storage container. I am going to select the container here through my subscription and my storage account. And for example, I've named mine training images, and you just have to drop the images in the format that they're on, a normal image format within the root folder of that container. So once we select the container, we have to allow Vision Studio to read and write to the blob storage, because what is going to happen now that we will see is that it's creating a data set and it's made basically an Azure ML dataset with those images for us, but then we have to go on to Azure ML and label those images manually in this case. So we will select a workspace and give it a new name here to make sure that we don't have one that is named the same way. I already created this workspace, but an Azure ML workspace is a different Azure resource, so you would be built for that individually for that use case, and you will have to go through the whole deployment process where you can see the different options. And clicking confirm, it's just gonna create a project on top of this data set so that we can label our images. And we can see that we are on the data labeling part of Azure Machine Learning. And the first thing that we see is this error message that we're missing label categories, and then we have 20 assets loaded onto the model, the project, but 0 have been labeled. It's at 0%. So we have to add categories. In this case, the model that we're going to deal with is going to differentiate between cars. So we can do car and bicycles. So we just generate these labels. It's important that you generate the label before you click on start, because once you have started your labeling project, you are not able to add any labels. So you have to stop it and then label your data. See, for example, here it says that you have to pause it to create new labels. And then once we move into label the data, we can see this intuitive user interface where it's just showing us our images and it's showing the label. It's saying, hey, you have to apply a label to this image. So for example, this is a car and this is a bicycle and so on and so forth until we complete this. If you are doing this through a notebook with pre-labeled images, you can also import your own Cocoa file into the Vision Studio directly, so you do not need to go through this labeling process manually, but you are able to do so if you so need to. And once you have finished labeling your images, you would come back to Visual Studio and you would go to add a Cocoa file. Because what we've basically done, with this Azure ML project, labeling project is created our own file, which is now stored in our own container. So for example, we're going to import it in this case from the project, and we're going to give it a name, and we're going to choose our subscription and our workspace, which in this case is the correct workspace. We can import and add this file. And now we can see here that it is added. It's basically a JSON file with the labels for our images. So our next step is to go on to custom models and to train a new model. Let's give it a name. And let's select again image classification. Then we are going to select our dataset that we just created, demo. And we can also choose an evaluation dataset. In this case, I am not going to choose one, but if you set aside a subset of your images for training, you can also do the same labeling on the side and then use that separate dataset for a validation report that will basically tell you how well your model trained. Next up, we can give it a training budget. As I previously mentioned, you are charged $20 the hour for training. So it really depends on what you need and how long you need to train for, how precise you need the model to be and what your budget is. And then you're just ready to train your model. We can see now that our model is on queue for training. Once you have hit training, you just need to wait until it finishes the training process. And once the model is ready, you are just able to try it out using the same UI that we previously used. And it will give you results based on the pictures that you have used to train it instead of the generic model that is pre-trained. And you can also use it with the API and just specify which model you're calling and that you're calling your previously custom trained model. This is it for today. I really hope you have enjoyed the session. Please feel free to demo these capabilities yourself within your Azure subscription and navigate in the Vision Studio to test out the capabilities of the different models and how they could help your use cases. Thank you very much.